Thanks for watching this screencast. The objective of this screencast is learners will be able to factor polynomials with two terms, either as a difference of squares, a difference of cubes, or a sum of cubes. So we're going to start by looking at a difference of two square terms. To factor any two-term expression where both of the terms can be written as something squared, like a squared minus b squared, a squared minus b squared can also be written as a plus b times a minus b. To think about why that's true, if you did FOIL multiply or the box method to multiply these two binomials together, you'd get a squared. You'd get a negative ab term and a positive ab term that would cancel one another out, and then you'd get minus b squared. So essentially, to factor a two-term expression where both of the terms can be written as perfect squares, you simply want to identify what those two squares are and then factor it in this way. So let's look at some examples here. Let's factor x squared minus 64. 64 is a perfect square, and so is x squared. X squared could be written as x squared. 64 could be written as 8 squared. So what I really have here is x squared minus 8 squared. And if I have a difference of two square things, I can factor that as x plus 8 times x minus 8. Just like with any other factoring, a good way to check your answer would be to multiply your answer back together and see if you don't end up with the expression you started with. Here's another example, 9n squared minus 25. Can both of these terms be written as something squared? Well, the thing you could square to get 9n squared would be 3n. 3n times 3n is 9n squared. Could you square something and get 25? Yeah, 5 squared. So if both of those terms can be written as something squared and it's a difference, then I could factor this as 3n plus 5 times 3n minus 5. Here's an example, another example, 49 minus a to the 4th b to the 6th. Well, 49 is 7 squared. Is there something we could square to get a to the 4th b to the 6th? Yeah, I think it's a squared b cubed. If I multiply a squared b cubed times itself, I would get a to the 4th b to the 6th. So, to factor this expression, I could write 7 plus a squared b cubed times 7 minus a squared b cubed. Okay, it's your turn to try this. Hit pause, see if you can factor these two-termed binomial expressions, and when you think you've got it worked out, hit play to get some feedback. C squared minus 9 is really c squared minus 3 squared. So we could factor that expression as c plus 3 times c minus 3. 100y squared minus 36z to the 4th can be factored if we can write both of these terms as something squared. 100y squared would be the same as 10y times itself. 36z to the 4th would be the same as 6z squared times itself. So I could factor this expression like 10y plus 6z times 10y minus 6z. Look at this last expression. 81p squared could be written as 9p times itself. 121 could be written as 11 squared, but do you notice what's different about this? Yeah, it's the plus sign in there. This is not a difference of squares. So this actually will not factor. This one will not factor. Now let's look at some sums or difference of two cubed terms. These also will factor. To factor a cubed plus b cubed, I could write one factor as a plus b, and the other factor as a squared minus ab plus b squared. And to factor a cubed minus b cubed, well, that will factor as a minus b times a squared plus ab plus b squared. Now, the memory trick for remembering these is right here. This is an image of a cube. You understand why I chose a cube? Yeah. A cube of soap. And soap is the part that I want you to remember. Soap is a memory trick for remembering the signs in the factored form of the sum or difference of two cubes. So the soap, the S in soap, represents the first sign, which is same. The first sign, the sign that goes with the binomial that you get, is the same as the sign in the original expression. The O in soap represents opposite. So the next sign, the first sign in the trinomial, will be the opposite of the sign that was in the original expression. And the AP stands for always positive. That last sign in both is a plus sign. So this is a good memory trick for remembering the signs of the factorization of the sum and difference of two cubes. Let's look at a couple of examples here. Let's see if we can factor a sum of two cubes. Can I write each of these things as something cubed? Well, x cubed is obviously x cubed. What would you cube to get 27? Yes, 3. 3 times 3 times 3 is 27. So, those are my A and my B. Let's factor it. That can be written as, x plus 3, same sign. The other factor has x squared, opposite sign. The middle term was a times b. In this case, this would be 3 times x, or 3x. And then the last sign was always positive, and the last thing was b squared, 9. So there's my factorization. X plus 3 times x squared minus 3x plus 9. Can I write both of these terms in a difference of two cubes? Well, 8a cubed could be 2a cubed. 2a times 2a times 2a. 1 is 1 cubed. So to factor this is a difference of two cubes. I need 2a minus 1. Now, the other factor is going to be this squared. So this squared is 4a squared. Let's see, same sign, opposite sign is a plus. Now I need this times this. 2a times 1 is 2a. And then always positive, I need this squared. 1 squared is still 1. 2a minus 1 times 4a squared plus 2a plus 1 is 8a cubed minus 1. Okay, pause the video and try these two. Can I write 1,000 as something cubed? Yeah, it's 10 cubed. So this expression really means 10 cubed minus z cubed. So to factor a difference of two cubes, I need this minus this as one of my factors, 10 minus z. The other factor should be this squared, 100, same, opposite. Now I need a times b, or 10 times z. Same, opposite, always positive. Now I need this squared, plus z squared. There it is. 10 minus z times 100 plus 10z plus z squared equals 1,000 minus z cubed. 27x cubed is 3x cubed. 8y to the 6th. What would you cube to get 8y to the 6th? Well, 2 cubed is 8. How about y squared? 2y squared times 2y squared times 2y squared would give you 8y to the 6th. So here are my a and b. To factor a sum of two cubes, I need this plus this, 3x plus 2y squared, times, now I need this squared, 9x squared, same, opposite. I need the product of this and this. I need 3x times 2y squared. That's going to be 6x y squared. Same, opposite, always positive. Now the last term should be this squared. 2y squared is 4y to the fourth. And there it is. Thanks for watching.